Hi, this is Gianluca from Oiltronic. Today we have a opportunity to test a driver for proportional valve with a particular form factor where a two-axis joystick is integrated. We can call it a driver with joystick integrated or a joystick with driver integrated, as you prefer. The device is produced by the company Fabercom SCANRECO. This device is a dual-axis joystick. Of course, this is suitable for driving double cylinder proportional valve, which can be controlling pumps or cylinders, of course, displacement of pumps or directional valve for cylinders. The driver is all integrated in this form factor. It has an output with a 8-pole Dodge connector, which has this type of pinout. You have power supply, two output for coil, common ground, and two interesting features. DV, that is a directional valve for the venting, for example, in certain case of application, and of course there is an output for a LED for fault indication. This setup we are testing today is including a junction box, a simple junction box, where we have connected all the output from the joystick. Of course, this part is not included in the price, or is not included on what you purchase with the code of Fabercom. You have so we have this box that is which is supplied by power supply. We have output that are going to a directional valve, and we have here analog amperometer, which in my opinion are the best method, the best type of sensor for current sensing. What we have to insist on is that this joystick is driver with embedded joystick is completely digital, so it's full digital. So there is a software which enable you to adjust several parameters. We can go online. When we go online, we have to activate a configuration file which is supplied by Fabercom. This configuration file allows you to see an interpreted type of parameters or variable and parameters. Once it is completely done, you see, okay, now it's finished. The green part are those that you can adjust. I have already adjusted the parameter of minimum current for at the value of 740 milliamps, the maximum current at the value of 1250. There are other settings available like ramps, like for example enable or disable of certain kind of input and output that are additional. We don't touch this stuff. Once you have finished, you simply press on save. You save this parameter on the device, you go offline, and then of course you can remove the connector, of course. Then we are ready to drive the proportional valve. Here we have, for example, these two coil, this double solenoid proportional valve. We have calibrated a minimum current of 740, so we can enable the joystick. So simply acting on the joystick, we have the two coil activated. They are calibrated in symmetrical way. So the minimum current that we have to manage is 750, which is here. And of course, increasing the angle of the joystick, the current goes up to 100 1150 because this coil is too heavy. Is a 18 volt, is an 18 ohm coil. But in any case, we are very close to the value. I should have a much lighter, heavier coil, which means with a lower impedance of value, maybe something like 5-6 ohm. Just for a typical test I do on drivers is to set a value of current and change the power supply voltage. This is a fast method to check the quality of current regulation of the driver. Now I will go down from 24.5 to 18 volt, which is the typical voltage where you declare a 24 volt battery is dead. And I go down, and even if you are decreasing the power supply voltage, the current is steady to 1 amp. And this is a very good news, because is everything that we need on a proportional driver is to have a current that is steady with the same reference signal. We can go down up to 16, and we will see that at 16 volt the current starts to slow down. This is because this device automatically is able automatically to understand if the main power supply is a 24 volt DC or a 12 volt DC. The same code goes 24 or 12, but of course if you make calibration on 24, they are not valid for 12. But within the range of the normal voltage fluctuation on a electric system for mobile vehicle, for example, which is minus 15 plus 10 plus 20%, the current is very stable. I'm surprised. Even I have also overheated the coil for a while, and the current is steady to 1 amp, same set point, same current. It's a very good driver from my point of view. There are other possibilities for calibration, of course, but everything that we really need is bias and scales, that is minimum current on the coil and the maximum current on the coil. So I hope this video is useful for you. If you are watching this video from any kind of social network, subscribe, please. This may help me. This doesn't cost you nothing and may help me to go ahead. Thank you. Goodbye.